in reduction formula. So this sin raised to nx in related to definite integral, so these are also most important, sin or cos. So in these two, one will be definitely asked. Evaluate completely 0 to pi by 2 sin raised to nx with respect to x for all positive, odd and even integral values of n. Okay, so here you have to evaluate completely for odd and even integral values, so that is positive, okay, for all values of n. So consider the nth term as in, so split up the term as n minus 1 and 1. Okay, so now it is of the form u into v, integrating by parts. First term as it is into integration of the second term sin x, integration is minus of cos x, limit value 0 to pi by 2, minus of integration of the second term, so that is integration of integration, so that is integration of minus of cos x into differentiation of the first term. It is of the form x raised to n, so it can be differentiated as n x raised to n minus 1. In place of n, it is n minus 1 is there. Therefore n minus 1 into sin raised to n minus of 1 minus 1, so it is n minus 2 of x. In place of x, it is sin x is there. Therefore differentiation of sin x is cos x with respect to x. So this is integration by parts. Okay, upper limit minus lower limit. Okay, so sine of 90 degree is 1, cos 90 is 0, so therefore upper limit is 0, minus of lower limit, sine 0 is 0, cos 0 is 1, therefore lower limit will also becomes 0, 0 minus 0, minus of minus plus, integration is with respect to x means n minus 1, we have to take it as common factor, 0 to pi by 2 sin raised to n minus 2x, cos x, so it is a cos square x. Okay, cos square x, trigonometric identity, sin square x plus cos square x equals to 1, therefore cos square x equals to 1 minus of sin square x. N minus 1 into 0 to pi by 2 sin raised to n minus 2x into bracket, so we have to substitute the trigonometric identity, cos square x equals to 1 minus of sin square x with respect to x. Okay, so now we have to multiply this bracket, that is n minus 1 0 to pi by 2 sin raised to n minus 2x into 1 with respect to x, this minus sin n minus 1 0 to pi by 2 sin raised to n minus 2x into sin square x, plus 2 minus 2 get cancelled, so we will get sin raised to nx with respect to x. Okay, and we are considering the nth term as in, so it implies that 0 to pi by 2 sin raised to nx as in and sin raised to n minus 2x as in minus 2. Okay, transposing the equation, in into bracket 1, this minus n becomes plus n, minus minus plus 1, so it becomes minus 1, so that is equals to in minus 1 into in minus 2. Therefore in is equals to, so this n goes to denominator part of RHS, n minus 1 divided by n into in minus 2. So this is the nth, so that is a reduction formula related to that term, call it as equation number 1. So this is not itself final because in minus 2 is there. So in order to find this in minus 2, because question itself is there, so we have to evaluate completely for all positive, odd and even integral values of n. Okay, so this is not the final one. In order to evaluate in minus 2, put n equals to n minus 2. So in this equation, if it becomes in minus 2, it is n minus 2 minus 1, n minus 3 divided by n minus 2 into n minus 2 becomes n minus 4. In minus 4. Okay, so substituting this in minus 2 value, so in this equation we get in is equals to n minus 1, n minus 3, this value, okay, divided by n into n minus 2 into in minus 4. So call it as equation number 2. So in order to calculate in minus 4, again substitute n equals to n minus 4 in this equation, so we will get in minus 6. Again in order to find that in minus 6, so we will get in minus 8. So like this, this series continues up to 1 to n number of terms. But here our intention is to find evaluate this value for all positive, odd and even integral values of n. So it is 1 or 2 terms, so that is sufficient. Call it as equation number 2. Case 1, when n is a positive odd integer, first we have to considering odd and next even. Odd, in is equals to, here in is equals to n minus 1, n minus 3, so on up to the n minus 1, n minus 3, n minus 5, n minus 7, so go on up to n number divided by n, n minus 2, n minus 4, n minus 6, and here it becomes I1 we have written, just concentrate this, how will it come, odd number. For this we have to calculate for odd number. Odd numbers means 1, 3, 5. Positive odd number. If you put odd number 1, so it becomes minus 1. But required thing is positive odd integer. Therefore, if you put 3, 3 minus 2, so it is 1. Therefore, it is I1. In is 0 to pi by 2 sin raised to nx with respect to x, but I1 we are writing 0 to pi by 2 sin raised to 1 with respect to x. So integration of sin x is minus cos x, 0 to pi by 2, upper limit minus lower limit, cos 90 is 0, minus of lower limit cos 0 is 1, minus of minus, so it becomes plus 1. Therefore I1 value is 1. Okay, so this is the formula related to when n is a positive odd integer. Okay, when n is a positive even integer, so if you consider the even numbers, so n minus 1, n minus 3, n minus 5, and in the denominator n minus 2, n minus 4, n minus 6, so on up to the n number of terms into I0 it becomes. How will it come? Let us see. So this is for positive even integer. Even numbers are 2, 4, 6, 8. 2, if you substitute 2 minus 2, so it becomes 0. Therefore it is I0. Okay, I0 means what? From the given nth term 0 to pi by 2 sin raised to nx with respect to x. If n value is 0, it becomes anything raised to 0 is 1. Integration of 1 is x, 0 to pi by 2, upper limit minus lower limit. So I0 value is pi by 2. So it becomes pi by 2. So this is the formula related to positive odd integer, and this is the formula for positive odd even integer. Okay, so this is general formula in related to above. While solving the example, it will be helpful. 0 to pi by 2 sin raised to nx with respect to x, that is n minus 1. Go on reducing that value by 2 in the denominator n. Go on reducing that value by 2 into pi by 2. Okay, so pi by 2 when it comes, only when it is an even integer. Okay, other if it is an odd number, so we have to multiply it by 1 instead of pi by 2. Okay, so these things we have already discussed on online class, even though it is an important one. So once again repeating this. Okay, as similar to sin raised to 0 to pi by 2 sin raised to nx, cos is also same. So here also we have to same thing. So we are evaluating this reduction formula for the nth term, that is cos raised to nx. We will get the equation number 1, and so in order to calculate this in minus 2, again we have to substitute in this equation. We get the equation number 2. So from that, positive odd integer and positive even integer, same thing. So there is no change in sin and cos. Okay, for positive odd integer, again we will get that I1 value. I1 value means that is 1. Okay, so similarly I2, so for even integer, so that is 2 minus 2, so it becomes 0. I0 value we have calculated, so that is pi by 2. Okay, similar thing. So there is no difference between sin raised to 0 to pi by 2, sin raised to nx, and cos raised to nx for all positive odd and even integral values of n. Okay, these two theorems are important, and the formula is also same. So there is no change. If it is an even number, then only you have to multiply it by pi by 2. Otherwise you have to multiply it by 1. Okay, so both sin and cos, while examples and theorem, so both are the same procedure. Okay.